Welcome. In this video, we are going to study about NumPy array attributes and arithmetic and statistical operations. We are going to study these attributes. So the first one which we are going to study is ndim. Ndim basically displays the number of dimensions of an array. The first one are one-dimensional array and these two are two-dimensional array. So when I write array1 dot ndim, it shows 1. So it means that it is a one-dimensional array. Similarly, if I write over here array3, it prints 2. That means it is a two-dimensional array. So ndim basically tells us the dimension of array. Next one is size. Size basically tells us the total number of elements in an array. So if I write size over here, it will print 9. That means total number of elements in this array is 9. You can use this size on one-dimensional or two-dimensional array. It will tell the total number of elements in that array. Then we have shape. It will tell us the dimension. For example, if I write shape here, it says 9, comma. So it means there are 9 elements in this array. Now if I use this on two-dimensional array, it will print 3, comma 3. That means it has 3 rows and 3 columns. I just print the array for you. You can observe that there are 3 rows and there are 3 columns. So that is why when I typed array3 dot shape, it has printed 3, comma 3. And for array1, there is only one row, and when I used shape, it printed 9, comma and empty. That means there are no columns. Then we have dtype. It displays the data type of an array. So if I write over here dtype, it prints int 32. We know that all the elements in an array have same data type. If I make it float, and now if I take data type, it says float 64. If I make it a string and run this once again, it will say U11. U11 means Unicode. So this way we can find out various data types. We know that 1 byte equals to 8 bit. So when I write array1 dot dtype, it says integer 32. Here 32 means 32 bit. So that means each element in array 1 takes 4 bytes. The last one is item size. We can find what we have calculated over here by typing item size. So this displays the number of bytes taken by each element in an array. So we have 5 attributes which we have studied right now. Now we will talk about arithmetic operations on NumPy array. These are the arithmetic operations which we are going to study. One is addition, second one is subtraction, then multiplication, then matrix multiplication, exponent, division, and then modulo. So first one, we will study addition. We can add two arrays by just putting plus sign between those arrays. If you observe array 1 and array 2, 1 plus 5 is 6, 2 and 6 is 8, and 3 plus 7 is 10. Similarly, if you look at array 3 and array 4, we can also sum up them. The addition will be performed like this: 1 and 5 is 6, 2 and 6 is 8, 3 and 7 is 10, and so on. Also, we can add a scalar value. For example, I can add 2 over here. What will happen that this 2 will be added to all the values in the array 1. Observe that all the values in array 1 are added with scalar value 2. The second one is subtraction. Similar to addition, we can subtract two arrays. Observe that 1 minus 5 is minus 4, 2 minus 6 is minus 4. This way, all the values have got subtracted. Similarly, you can subtract two-dimensional arrays also. 1 minus 5 is minus 4, and so on. Similarly, we can also subtract a scalar value. All the values got subtracted by 3. So 1 minus 3 is minus 2. 2 minus 3 is minus 1. Then we have multiplication. So what we can do, we can multiply two arrays by just using asterisk sign. All the values will be multiplied correspondingly. Similarly, we can multiply two-dimensional arrays. Here each value will be multiplied with another value. 2 with 6, 3 with 7. But for matrix multiplication, we cannot use asterisk sign. If you want multiplication like this, which is a matrix multiplication, we require at the rate sign between two matrices. So what we need to do is we have to put at the rate sign, and when we will do it, it will perform the matrix multiplication. The next one we have is exponent. So exponent is basically raised to the power. So what we can do, we can put double asterisk sign, and for example, if I say raised to the power 2, it will print 1 raised to the power 2, then 2 raised to the power 2, 3 raised to the power 2, and so on. We can also use another matrix over here. What it will do is 1 raised to the power 5, 2 raised to the power 6, that is 64, 3 raised to the power 7, that is 2187, and so on. We can do the same with the two-dimensional array also. Here we have 1 raised to the power 5, that is 1, 2 raised to the power 6, that is 64, and so on. Now we have division. But before we jump into this, I just wanted to explain you one very important concept. If I run 1 divided by 0, in Python, you will see 0 division error. That means division by 0. And if I write 0 divided by 0, still you will see the same error. So I just convert first value of this to 0. And now if I write array 2 divided by array 1, it gives me a warning, but it will print INF over here, right? That means infinity. Why it printed this is basically when I did array 2 divided by array 1, it is basically 5 divided by 0. So it has printed infinity. But if I run this command otherwise, it will give me this error. That is 0 division error. There is no output. If I run array 1 divided by 1, it gives me a value over here. So this should be kept in mind. Otherwise, you just need array 1 divided by array 2. It will give you the same results. It is just like 2 divided by 6. So that is 0.333 onwards, and so on. Similarly, for the two-dimensional array also, we can say like this, and it is just 1 divided by 5, which results into this value. Then we have Modulo. So for Modulo, it gives you the remainder. 5% 2 will give you 1, which is a remainder. It is a simple arithmetic operations. So what we can do, array 1 divided by array 1% 2, it will give you remainder of 2. So 0% 2 is 0, 2% 2 is 0, 3% 1, 3% 2 is 1, and so we can also do it like this. So that is 2%, 6 is 2, right? 3% 7 is 3, 5% 9 is 5, and so on. We can do the similar operation with two-dimensional array also. Now before we move to the statistical operations, you must understand this, that two-dimensional array have two axes. Axis 1 is for column and axis 0 is for rows, because in statistical operations we are going to use it. So you have to keep in mind axis 1 for column and axis 0 for rows. So we are going to work on these statistical operations. The first one is max. Max basically tells you the maximum value in an array. So what we will write np dot max, and inside that I will write the array name. So it returns me 9. I can also write name of two-dimensional array. It again gives me 9 because the maximum value in this array is 9. I just print this array for you. So this is an array. So I will use the statistical operation. So what I will do, I will write np dot max. Now I just wanted array 3, and then I write axis. If I use only this, it displays me the 9. that is the maximum value of the whole array. If I say x is equals to 0, remember that x is 0 is basically is for rows. So it will tell me the maximum of the rows. So if you look at this row 147, the maximum value is 7. 258, the maximum value is 8. 3 6 9, the maximum value is 9. If I put over here x is 1 and run it, the maximum value between 1, 2 and 3 is 3. 4, 5, 6 is 6. 7, 8, 9 is 9. And I just run it for you. We have another array. So if you look at this now, the maximum value of 5, 6, 7 is 7. 8, 9, 1 is 9. 2, 3, 4 is 4. So when I write x is 1, that means column wise, and if I write 0, that means row wise. Coming back, we can also do it like this, array1 dot max, and when I run this, it will give you the similar result. And you just need to pass over here x is equals to 1 or x is equals to 0. We can also do it like this. So that means there are two ways to do it. One is this, and another is you can also write np dot max, and then you can write array 4 comma x is 0. It will give you the same result. There is no difference at all. Then we have min. While max give you the maximum value, min gives you the minimum value. So when I used x is 0, right, that means 5, 8, 2, and we have 2 as a minimum value, 6, 9, 3. So we have 3 as the minimum value. 7, 1, 4. So we have 1 as the minimum value because we have used x is 0. So if I put x is 1, we have 5, 1, 2. So it is 5, 6, 7. So minimum is 5 and so on. So I can also run it like that. I can put over here. I just need to put min and axis to 1. For one dimensional array, you can't put axis. So if we use for array 1, what we can do is we just need to write array 1 dot min, right? So the minimum value in this array is 0. Next one is sum. It will give you the summation of all the values in the array. This is our array 1. So what we can do, we can write array1 dot sum. It will give you the summation of all the values. Or you can write np dot sum and then array name. It will also give you the same result. Now, if you use two-dimensional array like 3 and press enter, then it will give you the sum of all the values in that array. So this is our array. And now I use x is equals to 0. So what it will do, it will sum up 1, 4 and 7. So 1 plus 4 is 5 plus 7 is 12. 2 plus 5 plus 8. So that is 15. 3 plus 6 plus 9 is 18. If I use x is 1, it will do 1 plus 2 plus 3, that is 6. 4 plus 6 plus 5, that is 15. And 7 plus 8 plus 9, that is 24. Then we have mean, which gives you the mean of all the values. So what we need to do is we just need to put over here mean, and if I don't use access, so it gives you the mean of all the values. If I want to see the mean of one dimensional array, we can use it. And if I put access over here, so it will give you the mean according to the access. So that means 1 plus 2 plus 3 divided by 3. So I just run it for you. 1 plus 2 plus 3 divided by 3. So it is 2.0. Then we have 4 plus 5 plus 6 divided by 3. That is 4 plus 5 plus 6 divided by 3. That is 5. Then we have 7 plus 8 plus 9 divided by 3. That is 8.0. And if I use x is equals to 0, then 1 plus 4 plus 7 divided by 3. So it is 4. 2 plus 5 plus 8. So 5.0. So this is the importance of axis. Then we have median. So what we can do, we can type median and press enter. It will find the median of the values. Similarly, I can put axis over here and it will give me the median according to the axis. Then we have standard deviation and variance. We just need to use the name over here std and then array, for example array 1 or array 2 or array 3. So this is how we can find out the standard deviation. You can also use the axis over here. You can use axis 1. And the last one is variance. We just need var for variance and then pass array name. If it is 3, then this is the variance of the whole array. And if I write axis equals to 0, then it will provide you the variance according to the axis, which will remain same on each axis. So this is how we can calculate. We can also write any of these functions by just writing the array name and then the name of the function and then closing brackets. And if it is a two-dimensional array, you just need to pass the axis as an argument. So these are the statistical operations which we have used on NumPy array. Thanks for now. See you in the next video.